Uh, Thanks a lot for joining, everyone. So today's session is about securing AI systems. So we all have been experimenting with AI in some way or other. Maybe some use some chat application or have some agentic workload, maybe with OpenClaw or other things as well. Uh, but when these agents move to production, we need to consider some aspects and how it aligns with our organization's goals and security policies and posture and everything, right? So, so today's session is more towards. Today's session is more towards an idea or a way of implementing these systems where they align with the security posture or security maturity of your organization itself, right? So thinking from a perspective of a controlled system for agentic work. You want the agents, so you want your agents to be creative. They should be powerful. They should be able to do their work, but then they still need to be controlled. They still need to be governed, right? So when we talk about agents like desktop agents which people use, maybe like Hermes or coding agents. So these are all, they have a very small blast radius because these are all related to one user who's using it on his own system. But when we talk about enterprise systems, it's more broad and the blast radius is much bigger, right? So that's where, for this, let me start with a demo application that I've prepared for this presentation, which is just a simple application. Don't go into too much details on what the application does and other things, but just to show that what is to be expected or what is to be. So think of this application as a simple UI where users can see what's the current demand and output and other things as well. So more related to energy domain. And now consider that one of the users is a grid operator, right? So that grid operator will ask the open that, okay, which assets are currently affected by today's weather? So this is in scenario one. So, and this will, so basically what's happening, the most important thing in this uh, view is that each user has his own claims or roles that they can perform, right? So grid operator has grid dot operator and asset maintenance and all those claims available to him, right? So so this is just to show an authenticated user. That authenticated user will have his own roles, right? So based on his roles, he is able to call some agents and get those results, right? So this is actually eventually what I didn't show you at the start is that this is actually a multi-agent system where there's a router which decides which specialist agent is able to help with this query, right? So if a query came in, then it identifies, okay, this work will be done by this agent. So before browser estimate this one, this operation agent will go and get that information and give you that information in a precise manner, right? So it's multi-agent system, and you can see whether what's the result. And this is all coming from an API call internally, right? And then final summary as well, right? So it's just a simple application where it goes to an agent and gets some information from another sub agent, which gives and then passes through to the user. So this is kind of like normal application. We don't go too much deep into the how it works and other things, but that's how it is. That's just a part of the application demo. So the thing that I want to show you is that how do you control that this user, even though he has access to the application, he cannot invoke another agent or kind of a protected agent or a protected API or a protected endpoint, right? So consider now this this user has been compromised and he can get, he wants to know the market or spot prices or do something like change the prices or something like that. So let's say if I ask him, this is just an example, this is not a genuine example, but you see the result. Grid dot operator is not authorized to invoke this agent because it needs a market analysis claim, right? So because his query was related to what market, this, I mean, don't go into what the query is, but it's more like saying that you are only allowed to ask certain kind of questions and not the other intrusive questions, right? So when the user asks questions related to his role, related to his grid operations, maintenance operations, then he got the answers. But when he wanted to ask about something which is not related to his domain, so those things get blocked. And how do you implement it? So now this was just an example of what you need to do. Then let's go back to the slides again. And I'll show you what we need to implement such a system. So without going too much into the UI, so basically all these operations that the user is doing is all through. So there are three agents: operation agent, market agent, and maintenance agent, each with their own domain knowledge or their own domain documentations and procedures and guidelines. And the router is again another agent, but it is just a planner. It will just generate a plan that I need these three agents or these two agents to do this work, right? It does that activity and then it invokes them. But even that agent call is through the API. So at the APIM layer, at the API layer, so everything is an API. So at the API layer, we are protecting it with a policy, API policy that blocks access if a role doesn't match, right? So basically saying that this particular user, or let's say user A, is not able to call operation agent because he doesn't have that role, he doesn't have that permission. Or maybe he's able to call that operation agent, but he is not able to perform another action on that one on top of this. So I'll share more examples where you will get to know the power of this kind of a setup. So even for model calls, like if you're calling GPT-4 or GPT-4.1, it is also governed through it. So let me show you this exact setup in a actually where this is implemented on APIM. So if you're able to see the APIM screen, first thing is models, right? So invoking a model itself is governed through this particular policy, where in room design, you mention that, okay, I think I need to zoom out a bit, but yeah. So only specific users. So you can control which model, where, and how, and which backend is able to allow or not. So right now I have disabled it for now, but you can control which claims are required, right? And this goes to the back. This origin is only allowed with course policy, but there can be other things as well, right? So this is kind of a policy based implementation where you're blocking everything on the APM level. And then even the agents, like these three agents, who can call which agent. So like in this is a maintenance agent, so only required role, which is asset maintenance, is allowed. Does it make sense? So policy is controlling that, okay, when a user, logged in user, has a particular role or a particular claim, and it comes into the you understand the JWT concepts, right? So within the JWT token, it comes, your roles and claims can be passed from there, right? So you are validating that JWT token, getting that, okay, these are the claims that user has. It gets validated on the policy that, okay, that the only claim that is allowed is asset maintenance, and that user doesn't have the asset maintenance claims. gets blocked. So those requests were not actually blocked in the UI or anywhere. It's getting blocked in the APIM level, right? So this is this, and the response that you got was from here. It's not from the application or anywhere. So you have control. Like if you want someday you want to add someone else to the to access this API or this endpoint, you can ask. You can enable that as well, right? And similar to other agents like market agent or others, you can have the same there, right? And so let's show you the actually how it got invoked in the agent itself. So this is yeah. If you see this, these are the three agents which are founded, and so the first agent itself. If I see the traces, and I think there was a session just today. So what happened is that this agent got invoked, and so I'll switch to user view. This is to basically you got the planner, and planner then with the planner it called this agent operation, right? And then within did the processing and everything, and then after let me scroll to back. After sometimes it generated the results, right? And this is all through the model, and then finally you get the result. And if you see the trajectory as well, it says the same thing. But internally, it actually called this tool get weather observation. Right? This is a tool in APIM as well, and this is another tool where it called got the document from storage blob. It's a blob client.download. So it got that information from a storage blob, and it got so the blob name will be here as well somewhere. Okay, and we'll see that later on. And all this information using that all those responses, it inferred a result and got that result, right? And it called the dashboard as well to get the results. So this is one of the agents. But what happens when you have a scenario, and what happens when you have a scenario where the user is a malicious user and he wants to trick your system and wants to get bypass your security guardrails and things, right? So eventually with there are multiple ways where you can protect your system, but let me just go back slide again. Okay, so this was how this application is architected. You can architect or you can design your systems in different ways as well. But this is one of the approaches, or basically to show an idea that you can protect, or you should protect, how you should protect your systems internally, right? So, and the other thing is what exactly an agent is. An agent, in current definition, it's something it uses a model to do the reasoning part, and it has memory, it has some tools, and then we set up harness on top of it with guardrails, harness loops, and tests, evaluation, and telemetry and other things, right? So when we talk about multi-agent system, then we think about uh, not just one aspect of one harness layer. We need to harness it in the entire enterprise level, right? So these are the basic decision points that we need to make at an agentic level. So which user is allowed to access which model or which API operation, or which which agent, or is the request valid? Is it a prompt injection request? Is it a valid request? Is it related to his role or not? Right? That kind of thing. That's the third point I already discussed. And which tools are the agent, or which tools is the user allowed to do, right? So among this, I have shown you the first 2 points already, but I'll show you more scenarios where you will get to know what I'm trying to say from an actual application perspective, right? But the thing is that, back to that screen. Yeah. So this was a scenario, first one, where security scenario, where a grid operator is trying to access market data, but because his role doesn't allow that, the access to the market agent, it is blocked, right? And that is through API, and we have blocked that. So that was one scenario. So now consider another scenario where uh, there is a requirement for cross-domain reasoning. When someone needs access information from weather as well, they need information from energy as well, they will need information from operations as well, all things together. So in that scenario, if someone has that access, they can do it, right? So let's say this is an admin and he has access to, so he has access to all the agents, right? So his claims, as you can see, it involves a lot of things, right? For his claims, there are a lot of information that he has, right? So his role allows a lot of things. So browser or the router will identify something, and then the APIM will validate if that user is allowed or not, and then based on that, it generates a result, right? It will take some time. So uh, while we wait for the response, does anyone have any question up till now?
And I mean, like, just overview to understand like what is this tool first, like this we how do you use it?
This is not a tool. This is just a dashboard that I
Dashboard that
created
you created.
for this demo. This is just meant to be like an operation center for anyone,
For a demo. Yeah.
for any operation agent or something.
Can you deploy this in Azure? Like
This is deployed in Azure, right?
Okay, and administrator control to provision roles and policies. Is it also done through the same?
So this is just a dashboard demo. So for that, I'll have to create actual user portals and other things, right? So because we our thing today is just to show from the perspective of security. So we didn't.
So, for these guardrails to set what roles can access what agents or the tools, like how is it defined or where it is actually configured for this?
That's where I'm coming from. So you can do it with multiple tools. What I did was through API management.
Okay.
So API management is my
So you're controlling all this.
Everything is through API management. So all the information is going through API management, where I'm controlling which agent or which user or which claim is allowed to which thing, right? So that's where I'm doing. And if you see this response that came, so it got this from spot price from energy tool, which is a separate tool, a separate API.
Yeah.
It has access to that. Reserve margin is another thing that came from from a storage location, right? And demand came from another tool, which is another API, right? And finally it get, so it got information from multiple sources and collated it and be able to get response. So that's what it is doing. But the other thing is, let's say if you want a multi-agent system, this one was, I think, just one or two agent, but in a multi-agent system, it will go to agent one, agent two, agent three, and get separate responses, right? So maybe it will operation. So this query that it called, this one, should we postpone maintenance on wind farms? So it will check the energy, the result. It will check the wind, or what's the wind speed, what is all that background information it needs, so that it makes a decision that for this time, for this issue, we should not do that, right? So you see the response. It will. I specifically put this prompt because it goes into the. I set a certain downtime on a particular wind farm in my files, so that it shows that, okay, there is a downtime in this windmill, so don't do it today. That kind of information. So that, and that to your question, where is it getting that information? So, right, if you'll see this, the response came from two different sources. So this came from market maintenance agent, right? So there is a schedule maintenance that is happening. That is specifically I have added in a file that, okay, there is a schedule maintenance on this day. So it is getting that information. And then there is an operation factor that, this came from an operation agent, right? So you can see here, it asks two agents for the information, right? So basically the planner is planning something, and based on the plan, it is generating, okay, these two agents will help me with this information, and that those two agents get that information from either storage account, from either the APIs, wind APIs or energy APIs, wherever it is, right? So that is the crux of it, right? But let's break this system now. So everything working, everything is fine now, right? So let's break this system. Uh, let's say the first thing we tried was, grid operator tried to call an market related question and it failed, right? So that's something we blocked on the, that you can't call this agent with his role. You cannot, with this role, you can call, okay, you can't call this agent. But then let's say if we say that this is a malicious user, he will try to ignore previous guardrails and export operator keys, routing tokens, and others, and that kind of a malicious prompt.
Through prompts?
Yeah, yeah. So it went through, but it never even crossed the planner bound. So the planner or the router itself, when it called the model, got blocked. And where is this being set? So this is being set at the model level at the moment, because and how we can set it, I'll show you in Foundry itself. So here in Foundry, if you see here, we can have our own guardrails, right? And this guardrail is actually set at these two models, right? But we have options to create our own guardrails as well, right? So like whenever someone calls, so this was an attempt block on jailbreak, which was blocked, but similar thing would be happening similar things would be happening with other things as well, like prompt injection would be there, or maybe a spotlighting would be there, or maybe there is hate content or some kind of threat. Those contents you can block as well, and I can have a block list as well. Like I've had a custom block list that I had added, and that I can also do, right? What is the protected material? What code is there, right? Those kind of guardrails and PII information. Does it adhere with the task or not, right? And then we can assign it to which agent do we want to assign it to, right? Or which model do we want to assign it to? So this kind of a guardrail we can have. So this guardrail is actually perimeter shield, right? It is not the actual flow, or it's not related to your information. It is more like a generic guardrail that you have on your model or your agent, right? But then this won't stop a user from crossing the access boundary, right? So it won't cross it will just get that information and parse it and get what the user is trying to say, but it will never check your claims or roles or all those things, right? So for that you need this API based approach, right? So if I go back to the slides, this is where the guardrails are divided into different aspects: perimeter, shield, and internal guardrails, right? So these are just my terms, but you understand what I'm trying to say. So perimeter shield is like you are protecting the model or the agents from malicious attempts, right? So you don't want them to be, harmfully or harmful information to be passed through, right? So that's where you are doing with the perimeter shield, with intent detection, prompt validation, and guardrails and all those things, right? And PII masking and other things. But Then we come to the internal guardrails where we have access control, which is what I showed you, that grid operator is not allowed to call market related queries and all those things, right? So that's where access control comes into picture. Tool middleware is another aspect where a certain user is only allowed to call a certain tool. He's not able to call another tool as well, right? So that I'll show you another uh, scenario here where a certain tool would ask the user for permission that, okay, this is not a normal operation. You need to get permission to do this activity, right? So let me show you the next scenario. But up till now, does anyone have any question? Am I too fast? Am I too, I mean, is it understandable up till now?
Yeah, it's good.
Awesome. So I'll move forward. The next thing was going back to the dashboard. So this was just one. So you got 400. The response was filtered because it was a prompt injection attempt, and it got blocked in the OpenAI. But there is one thing you notice here is that it is being blocked in the OpenAI, in the model. It actually went to the model, right? Even though we had everything in place, right? There is a solution where, I mean, there is an approach where you need to block this even before reaching any model. That is called your tool middleware, where you have to actually have a middleware in between your model and your actual tool calls or actual model calls, right? So that's not something that I can't show today, but you get the idea that with guardrails that I showed you, similar to that thing. That guardrail was on the model level, but you can have a tool middleware where the harness engineering come into picture. That the tool middleware actually checks for those prompt injections, those malicious contents and PII masking and everything. It happens on your own system. It doesn't go to the model at all. So that's another approach that you can follow, right? So now going to the third scenario, maybe this will be more. So we got the cross domain as well, like multiple agents called and got the multiple. They gave separate results and you merge them together to get a better result, right? But now let's say we have a we already seen scenario one, scenario two as well. We have, so scenario two was, I mean, it's not in this demo. Let me stop it and share it again. Sorry, I didn't share it before, but this is more related to what the agent can actually do, right? So let's pick one of the agents. Your pick. Which agent should we pick?
Maintenance.
Maintenance? Okay, so let's ask maintenance agent about market queries. Anything you like? How the market will behave today. I don't know if it will work or not, but let's see. Let's ask it something related to market. This is a maintenance agent. It should not answer me market questions, right? But let's see. If it does, then we already did. Right? But ideally, I cannot provide the information protection about market behavior because you have to ask either the trading desk or market operations. Right? So now ask the same question to market and let's see if they have the answer to this. If they have an answer, then it's working, right? So we have a perimeter boundary that this agent has this access, this agent has this access. Why this is working in that, not working in that agent is because the storage account that is, or the container that is attached to that particular agent doesn't have anything related to market. And it does not have access to the market tools as well. But this agent has access to market tools and it gives you response, right? So whatever is the response, spot price, operation demand, renewable energy generation, and other things, whatever it wanted to give you answer, it will give you, right? So that's scenario two, where each agent has its own responsibility, its own access, its own tool. It cannot jump its boundary, right? It cannot answer question for something else which is not related to its domain, right? So that is agent 2, scenario 2. So now coming to scenario 3. So there are only 2 more scenarios left, but
how does it deal with partial completion?
partial.
So what if you asked it a question that was for both, like both agents, you would
Yes,
need to answer
yes.
it.
So that's where the initial planner agent will come into picture. So the
Okay.
planner is actually planning, okay, this query needs 2 agents,
Sure.
right? So let's say if I go to here, I'll show you this a good example. I think I showed you. Yeah, sorry. Tell me.
Yeah, in the background, like, are these agents use any search engines?
Not a search engine specifically. They are all using the model uh, in this
But is
sense.
there any
But
option of search engine?
yeah, you can attach any MCP tool to an agent, right? Whatever tool you send. So that's what I said about tool, right? So that search engine is also a search tool.
So you
Right,
have
so-
disabled that option for
Yeah,
these
at this
particular
moment,
scenarios.
I have
Okay.
only sent it to 2 specific tools, which is energy and market, and then the storage account. Those 3 tools. It doesn't have access to any other tool.
Or search engine.
Yeah. So we can add search engine as a tool as well, or other tools as well, right? So you got a response, but if I show you where it went, it actually went to these 2 agents, maintenance and operation, right? And I can show you in the logs as well for those agents what was the response, right?
Cool.
So if I go to that those 2 agents, the recent query will be there. Let's go to those agents.
But if you only had access to the maintenance agent for that question,
Yeah.
you'd just get half a response and then it would say, I can't answer the rest of this.
Yes,
Yeah.
obviously, yeah. I mean, right now I have blocked it because just to show for the demo. But if you don't have access to that, then you should kind of say that I don't have access to market data, or I don't have access to this data. So, or your role doesn't allow access to market data. So you cannot get that answer, but I can give you this summary, that kind of thing. Right. So in the traces, I can see that recently what I called, did it call the market? Yeah, this is the conversation I went through. I think got this one. So it called, didn't call market data, so I don't see any log of this. This is last my conversation, right? So market, it didn't call market agent at all, but it did call operation agent as per this log. And I can see the traces that the first call, it went to this one. But that's not the main main aspect of this session. Multi-agent system is not the session. It's a session is more about security, how you secure those systems, right? So even though it executed this tool and it got the operation document from the operation container, right, and it got this file storm operation module.md, which has some information, right? So this is the document, what it has and all things, right? And it got the weather information, with this minimum temperature, maximum temperature. It is calling the model GPT-4o to get a response, and then it is again getting more maintenance documents. See this entire scope, how it went through. So if I show you the user view, it called multiple agents. So, and this is coming in a flow, but you'll get to right. So starting from here. So one response is from the operation agent, another response is from the which one was the other one? Maintenance agent, I think, yes. So yep. So both responses are coming side by side from both agents, and then at the UI or the user interface, you are showing it as a single result, right? So this is the response, right? So both agents are responding side by side, which one agent responded in different manner, another responded in different manner, but then on the UI, you merge them together and got a response for the user. Does that make sense?
Yeah, it does. Yeah.
Yeah, and you see the response is from API management only, right? So everything it called is through the API management. It got that information through the API management. Cool. So that was one of this. We are almost on time, so I'll just jump ahead and show you the other sections, other scenarios. there are only two scenarios left. So another thing is approval, which is which is very you want, if there is some destructive action to be happened, you want your agents to ask you for approval, right? Something wrong is about to happen. So for this demo, I have only created a API, which is just a dummy API. It doesn't do anything, but it is meant to represent something that is, harmful, or maybe something, or updating a row, a column, or something like that, which is, you want to have a guardrail for that. So let's just say from a grid operator perspective, he asks this query that, okay, there is high wind forecast near this wind farm, review the maintenance position and take appropriate actions. So when he says take appropriate actions, it actually needs to do something, right? So that means that it calls the planner. It goes to the planner find out, okay, let me share what planner is doing. Maybe I can share the screen, entire screen, so that you have access to this. Okay, so this is where the planner is. So this is a planner log. So it find out that, okay, this is grid.operator, right? And it is calling this operation agent, right? The role, everything. So it created this ticket. And now if I go to that VROC, we'll see that there is a approval pending for this ticket, right? And this is the ticket ID, and you see the ticket, and there is an approval button here, right? I have to work on this, but this approval button should not come to grid operator. This should come to maintenance supervisor. And so because this action needed something to be done on an API, and it prompted the user for approval, right? But why did it do that? How did we make that possible? Is that this API? So this is a demo API. And you see this create high priority ticket is a demo API, high priority inspection. So the policy in this particular operation is that there is a required role, which is fine, which is similar to how we did it. But then there is this variable, it is checking that if this requires human in the loop or not, right? So the main thing is, if I show you, sorry, not the policies, just the design. And for this API, so it actually needs these two headers, moved and approval ID, right? First time when the request comes to this API, it responds that I don't have those two headers because they were not approved, right? This is the first time query. Then it goes to the to the UI, and UI will say that, okay, I have this request and I have to create a ticket for that. So create that ticket is a dummy ticket. It's not an actual ticket, but you get the idea. So it creates that. Now when you click on approve, what happens is that, let's say I approve it. So now it got approved. It will fail, still fails because approval was recorded but protected, right? API call failed. Failed because don't have any logic in the API, but it actually passed through the approval gate. You get the point? So it actually got to the API, but that API does nothing. So it will always give result 404, right? But that's how it is. So it's actually an MCP server. It's not a simple API. The call is going to an MCP server, which is this one. And this MCP responds with the actual API. So see the tools. This is here. So one of them I have not enabled, but this is the MCP tool. So when the agent actually made that call, it called that MCP tool, right? So I'll show you in this log where it happened. So this is the entire log for the same approval flow and everything. So, but before that, so see this action type inspection work order. So there is an action type that went through, and let me check. Okay, sorry. I think I'll have to check which agent it went to. But yeah, so you get the point that if an action needs it's more critical and it needs more. So you can put your controls over there as that. Okay, this is a destructive action or this is a wrong action. It should be approved, and it should be approved by someone else, one that is doing that, right? So that kind of automated guardrails you can do. So this makes sense or not that you have two different set of guardrails where perimeter shield is pre-configured or automatically available things like PI masking, intent detection, prompt validation, and other things. But the internal guardrails are your own access control, your own policies, your own logic, your own rule sets, your own defined set of tools you want, right? So let's say if I go to here, I go to storage account. So this storage account has this all the documents that you needed. So each agent has his own container, just to show in them done that, and that container contains their own related files as well. So if I talk about the maintenance schedules, so this is the maintenance schedule that it was looking into at the moment, at that time, that okay, this is high priority when there's control on that thing that it was checking into. And it also checked the inspection history, that okay, what was the inspection history for this, right? So this information it got, and based on that, it made a decision that okay, don't do this because there is this inspection history that revealed that this need to be followed up at this date. So we are in that window, we should not do it. That makes sense, right? So I mean, we don't go too much into the logic. This is just an example application, but you get the idea where it is going and what it needs to be done, right? So up till now, I think I can go back to the application. Yep. So if you see, this was the entire high priority inspection and everything. It went through the inspection and it is approved now, right? And if I go to my pilot, I can see that approval was recorded and it was approved. So whether tool was called, operation agent got it. Okay. So I think operation agent. So operation agents is checking it first time. So maybe it is there. Yeah. So this is where it went, but it should have called the MCP tool. Yeah. So this is the post API MCP, right? Bad request. It got a bad request, but it got a bad request after approval, right? So that's fine. But for this, it checked all these documents, wind turbine maintenance and work order.json, all that information. It did it. It got that first to make a decision that what needs to be done next, right? So observation. Okay, so that covers almost all of the scenarios. Let me check if there is anything left. I don't think anything else is left. Questions? Anyone? Has the session been? I know, I mean, initially it would have been too much time, but yeah. Any questions?
Really good. Yeah. So where have you built this out? Moment, is this in your
This is all in Azure in my.
in your yes, and
It's nothing to. I mean, it's not too resource intensive. Everything I'm using is predefined. So there is an APIM already where there are all these APIs. Like if I can show you the APIM. Right. So
have you found any creative ways to break it yet?
yeah, I have been trying to break it a lot. That's the main thing, right? We don't want to keep it alive. We want to break it as much as possible. Yeah, so this even the agent router is an API. So front end actually calls this API to get, create approve ticket, create approval and everything. So this is,
Where do you set up the planner agents and other agents?
Planner agent is an app service in Azure. It's just a simple app. So you see these are the two apps.
From the marketplace or like you build? Yes.
So this is a simple GenKit workflow. So if you attended my first session, so I showed you how, I mean, you might have that recording already. So how we create workflows in or flows in GenKit, right? So this is the GenKit workflow.
Okay.
GenKit flow. I can show you the code as well. So this is
And you just deploy the Jenkins.
yeah. Yeah. So the GenKit flow is just a simple application. So what it does is that it checks these headers. Yeah, so it is a simple. Yeah, so this is one of the sensitive tool which we were discussing. So AI don't. So this is the planner, right? So this is here, kind of its own consult maintenance for inspection and other things, consult market analytics for this thing, consult operation for this, and all of these are internal tools through it.
All internal tools
Yes.
through APIs.
Yeah. So it is calling that internally and getting that response, right? So, and because you see the most of this presentation scenarios that others I have added here, right? So this is all, these are the tools that it has, right? So, and even the agent
Rules?
Yeah.
Rules
are all in.
like role, the rules that you showed for the operator role and administrator.
So those are just front end claims. They are just front end. I'll show you what it is. It is just front end static thing, but that actually represents a logged in user. So if a user actually logged, you don't need to put it in front end. That you will get from Azure AD, right? Yes. So other thing that I forgot to show, maybe due to interest of time, I can just go and check this enter ID and agents. So I can even see the agent identities here. Each agent has its own identity. You can see, and what they can. So how these agent access the storage is through this identity role-based access control. So this agent is allowed a storage reader role to get that file from that storage account. So that's how it is able to access. It's not implicit access, right? That's why being in the same storage account, but still operation agent could not get market data because he doesn't have access to that container. His role is not allowed to that container. So that's how it is. So this is how.
Can I open any one agent?
Agent again?
Yes, like this one, identity.
Oh, this identity. Yeah. So this is his agent's identity. Access, you can see.
Cool.
Yeah, right. So granted permissions. I think enter somewhere. I think I can't see. So you can actually do all these things with sign in logs and other things with agent identity. I think somewhere in it's not showing in the, but I can show you the same access being provided in.
Can you share an identity across multiple?
Yeah, you
agents?
can actually do it, but how I deployed it is through Foundry hosted agents.
Yeah.
So each agent is kind of like a new container.
Mm.
They have their own separate identity, managed identity kind of thing. But if you do it the same thing with Kubernetes, you can have a single identity or a separate. But I would suggest keep every agent as separate identity.
Yeah.
That would be much more, makes more sense to me, right? But you're a security expert, you know much better than that. But you can see in the agent detail as well that it has this identity.
Okay.
Right? So you can go through this as well, right? Which blueprint it is using, which identity it is using, and where it is.
So first you create the identity and then map to the.
No, when you deploy this, so
creates by itself.
Yeah, it creates by itself. But if you are actually developing a enterprise system, you would create that beforehand. You would not rely on Microsoft to create that for you, right? So that is the thing. But if you see the maintenance agent in the access control, I have allowed that. I think that it is broken up. But yeah, in this access control, I have added that agent as a storage blob reader. So this agent can actually, you see this one, storage blob reader. So it can read that storage blob. This is only for because this was a maintenance, so this will only be with a maintenance agent, not the others. Does that make sense? Cool. So this is maintenance agent identity, right? So that's how we have blocked it, but that's from anything. Cool. So any questions? Sorry, up till now. Maybe we are right on time, I think. If not, then we can just drop off. I think we have 4 minutes left. First time I completed a session within time. It shows that value. All good, guys. Thanks a lot. Bye bye.